To the very first video on my channel. Today we're diving into the Pythagorean Theorem. We'll explore its origins and how and where it was discovered to give you some historical context. That's at the end, by the way. Then we'll break down how to apply it and discuss its potential uses. So I'm explaining how to do it and then giving some context at the ends. Anyway, so the Pythagorean theorem states that in a right-angled triangle, the square of the length of the hypotenuse, the side opposite the right angle, is equal to the sum of the squares of the lengths of the other two sides, known as the legs. This is represented by the formula a squared plus b squared equals c squared, where a and b are lengths of the legs and c is the length of the hypotenuse. Basically, all that told you is this was equal to these two squared. This is the hypotenuse right here, this side right here, the longest side, and these are the legs, the shorter sides. This is C, the hypotenuse is C, and the legs are A and B. Let's say the hypotenuse is 5. And let's say leg 1 is 3 and leg 2 is 4. Now using this formula, a squared plus b squared equals c squared. So now we can now using this formula, we can simply plug them in and we get 3 squared plus 4 squared equals 5 squared. Or this stuff right here. This shows it's correct. Yeah, so this is just the basics. Let's do something harder, alright? Let's say the hypotenuse is 10. Let's say the first leg right over here is 6. We don't know the second leg. We don't know A, so it's X since we don't know it. Don't worry about these. For this equation or question, we are gonna need some good old algebra. We put down the formula, and then we plug in the numbers. We do the math on what they actually equal. We minus 36, we get this number. We do the square root of b, meaning that we have to do it to both sides, so we have to do the square root of 64, and we get b equals 8. Boom. And if we plug that number back into the formula, we get this, which equals this, which means it's correct. Anyway, the Pythagorean Theorem, the well-known geometric theorem that the sum of the two squares on the legs of a right triangle is equal to the squares on the hypotenuse, the opposite side, the side opposite the right angle. Or in familiar algebraic notation, a squared plus b squared equals c squared, although the theorem has long been associated with Greek mathematician, philosopher Pythagoras, c. 570 to 500/449 BCE. It is actually far older, for Babylon tablets from circa 1900s 100 to 1600 BCE indicates some knowledge of the theorem with a very accurate calculation of the square root of 2. The length of the hypotenuse of a right triangle with the length of both legs equal to 1, and lists a special integers known as the Pythagorean triples that satisfy it, e.g. 3, 4, and 5. 3 squared plus 4 squared equals 5 squared. 9 plus 16 equals 25, aka an example I showed you earlier. The theorem is mentioned in the Babylon Sobers, I don't know how to say that, of India, which was written between 800 and 400 BCE. Nevertheless, the theorem came to be credited to Pythagoras. It is also proposition number 47 from Book 1 of Euclid's Elements. This quote is taken straight from Brenica. Okay, this site, and it's this site right here. Anyway, basically all you need to know is this theorem is pretty old and was taking credit from someone else. Boom. I'm pretty sure this part is true. That's what it was in the theorem here. Anyway. Alright. That should be all you need to know. If I missed anything about the Pythagorean Theorem, then tell me in the comments or email me. Please like and subscribe. I'm planning on trying to make educational videos and more that can be watched by anyone. Published by Cookie Man Studios. Slide made by Cookie Man Studios. Thank you for watching. And name's Mr. Cookie. See you later.